Hello, this video is section 2.2, more graphs and displays. All right, let's see what we have here. First one we're going to look at is called a stem and leaf plot. It's a weird looking plot when you first see it, and then, once you kind of get the hang of it, I know from like doing this face to face, people look a little confused, then they get that aha moment there where they, oh, okay, now it makes sense. So, okay, we'll see what happens here. Good news, being a video, you can rewind me and watch me explain it as many times as you want. Now, a stem and leaf plot consists of a vertical line, and on the left side of the line we have what's called your stem, and the right side you have what's called a leaf. All right. And let's take a look at this data. So you see numbers 12. A lot of times people forget about, look at this, there's 12, and then all the way down there is a 41 on the next row that is part of our data right there. So these are the values. Now your stems will be multiples of 10, and the leaves will be multiples of 1. Sometimes these could be decimal. Now that's what this key is all about, which I'll tell you what that in more detail, but you're not going to really have to worry about the key that much, but I am going to explain to you what its purpose is. So the stem, the left-hand column, 1, 2, 3, 4 means 10, 20, 30, 40. The leaf column is the ones digits, So what you do, and you generally want to put these in order too, even the leaves should be in order. So what you want to do is you got these stems, then you look at your data, the number 12. The number 12 means you've got a stem of 1 and a leaf of 2. So you put a 2 right there. 13, a stem of 1 and a leaf of 3. So the important thing to consider here is these values on the leaves are not interacting with each other. They interact, they all work off the stem. They're not related to each other, but they're all related to the stem. So in other words, I'll draw this and then I won't save it in the notes, but let's use a different color, I guess, than red. But so in other words, 1 with 2 makes 12. 1 with 3 makes 13. So forth and so on. So they're all branching off that stem. Edit. All right. So now the next one, 21, we have a 21 and a 27. So it'll be on the stem row of the 20s. And then a leaf of 1. So 1 with 2 makes 21. 7 with 2 makes 27. The next one, we have a 33, a 34, and a 35, and a 37. So we have a stem of 3, and we have 4 leaves, a 3, a 4, a 5, and a 7. So 3 with 3 is 33. 3 with 4 is 34. 3 with 5 is 35. 3 with 7 makes 37. The last 3 numbers are 40, 40, and 41. So if numbers repeat, they have to have their own stem. That data has 2 values of 40, so it needs to be represented twice here. So 4 with 0 makes the first 40. 4 with 0 makes the second 40. And then 4 with 1 makes 41. So notice that here's like a frequency. They broke these up into, they might not have done the specific calculation that we normally do to get a frequency distribution, upper minus lower divided by number of classes. I don't think they did, but that's okay. They just chose to round it by tens. We're going to stay with that formula, but that's why sometimes a statistician can, be a little flexible with it if they want to, but you'll want to do it the way we do it, especially like you saw, we already had that in the homework section from 2.1. So let's see what we got here. But you can see that the frequencies here, and they did it this way because of the whole idea to match the stems. That's the reason why they did it this way. And look at the number of leaves match the frequency. So you see there's 2 leaves, frequency 2, 2 more, another 2. There's 4 leaves here, frequency 4, and 3 leaves for that last one, frequency 3. Okay. Let me see if I've got that. I'll wait. Well, I'll mention real quick about, I don't think you're going to encounter this, but I'll mention what the key thing could, I don't think you'll need this, but I'll mention it anyway, is suppose that you weren't looking at the original data like we were in this problem. We saw the data, so we know that they are whole numbers. But suppose you're only looking at the stem and leaf plot. This key is just shown to represent any one number. So it's saying if 1 with 2 makes 12, then they're all going to be whole numbers. But somebody could actually do this for decimals if they wanted to. So if they said 1 bar 2 equaled 1.2 for an example, that means every value in this data set would be something point something. So it'd be 1.2, 1.3, 2.1, 2.7. So that's the reason for the key, even though I don't think you're really going to need it. But I just wanted to at least tell you why it was there. Now this data, I already have it sorted out for you here. And as I say, once again, it's showing that it's whole numbers, but we don't really need the key because we can actually see the numbers. Now it's very important, and I did this on purpose. When you have a stem and leaf plot, you're seeing you're going from 20s to 70s, that every stem must be represented, even if it doesn't, from lowest to highest, even if somewhere in between doesn't have any leaves. They still need to all be represented. Now you don't put, like, since it goes to the 70s, you wouldn't add on empty leaves like 8, 9. You don't do that. But I did this on purpose, and I created this data set where it has no numbers in the 50s. But that 5 still needs to be there because it's just part of the pattern. So you would have, since it goes 20s to 70s, you have to go 2, 3, 4, 5, 6, 7, even if there's any empty leaves in between, which there is for the 5s. Okay, so 21, 22, 22, 24, 25, 26 gives me leaves 1, 2, 2, 4, 5, 6. 30 and 35 gives me a 0 and a 5 here. 41, 46, 47, 49 will give me leaves of 1, 6, 7, and 9 to go with the 4. No 50s. Obviously, don't put a 0 there because that would mean the number 50. Same thing with the 60s, and I think you see how this probably works by now. Anyway, now it's not bad on how to construct one, but what I like about these kind of graphs, as you'll see in this section, is suppose we're just looking at the graph, and can you answer basic questions, mainly like proportions and percentages, relative frequencies, based on what you're looking at. And I think that's an important skill, and it's not difficult. So without it, pretend like you're not even looking at that data set. Just pretend like you're only looking at the stem and leaf to answer this question. It says, what proportion of the values are less than 50? Proportion, fraction, decimal, percentage, relative frequency, basically. Now, suppose it didn't tell you how many numbers there were. Does that mean you have to take this stem and leaf and you have to rebuild all this over here? Not at all. You do not need to do that. The number of leaves tell you how many total numbers there are. The number of leaves, because each leaf pairs with a stem. So you see there's 6 leaves, 2 leaves makes 8, 4 more makes 12, 7 makes 19, 6 makes 25. So that's how you would get how many. There's 25 numbers, is there's counting the leaves. And you can see that I'm dividing by 25. I used percent, but obviously it could use decimal. They could have 0.48. Obviously, on a test, it'll be easy to recognize. The answers would either be all percentage or all decimal, same units. Now, of course, in the homework, it's very picky what it wants, so it tells you it tells you the number of decimal places. Do whatever it says. Less than 50. So once again, do I need all these original numbers to do this? I do not. Because all I got to do, less than 50, is going to be all the leaves that go in the 2, 3, 4 stem column, because those are all going to be numbers less than 50. So I just count out the number of leaves in these first 3, because they'll all be less than 50. 6 plus 2 is 8, plus 4 is 12, so it's 12 out of 25, which is 48%, which is also 0.48. So there you go. So that's kind of a skill to be able to sort of see how to read that. All right, here's another question. I was asking from this stem and leaf. What would be your minimum value? What would be your maximum value? So the minimum is going to be the 10 with the 2. Oh yeah, you can have it like this. This makes the numbers in the hundreds. So it's like 10 times 10, 11 times 10, so forth and so on. So basically it's 10 times 10, it's 100 plus the leaf of 1, so that makes that number 102, 102. That's your smallest one, and then 13 with the 6 makes 136. And you see the key is also then telling you, so the key might be helpful here to let you know that that does mean 10 with 2 represents 102. What proportion are less than 120? Count the leaves. 5 and 2 is 7. 8's 15, 3 more is 18. There are 18 leaves. So that's my denominator. And less than 120 would be everything in the 10 and the 11 rows. So 5 plus 2 is 7. So it's 7 out of 18. Dot plots. Okay, dot plots are really easy to construct. The idea is that you have a number line, and then every time you have a data value, you put a dot above that number on the number line. So I'll kind of walk through this here. I'll kind of just minimize the eraser size here. It's real easy. So you put a 2, and that's going to represent this dot right here on the bottom. 4 represents that dot. 3 represents this dot. 2, another 2. So anytime a number repeats, you stack the dots. So that second 2 would be that second 2 right there. And you just keep stacking the dots as they repeat, and then there's your dot plot. Now this is not scaled perfectly. I just to have enough width, maybe I could, I don't know. It's 30 would actually be farther out there. You see that 30 right there at the end. But this is a term we're going to be using frequently in this class, outlier. So we're kind of getting introduced to the idea of what an outlier is. But in general terms right now, an outlier means a number that's far removed from the data, either high or low. You could have a bunch of larger numbers than have a small number as your outlier. So it works both ways. So if I had this scaled a little bit better, you would see that 30 visually would be even farther away than it is here in this picture. But yeah, that's the idea of an outlier, but we'll see more precise ways to determine it. But that's just the general definition of what it means. Okay, what proportion of the values are less than 4? You can either count, if we didn't have these numbers here, you could just count the dots. 2 and 4 is 6, 7, 3 more makes 10, 11, 3, 14, 15, and don't forget your outlier out here, 16. So if we didn't have those numbers and we were only looking at the dot plot, we could figure out that there were 16 numbers in that data set just by counting the dots. So everything's out of 16, which of course may be expressed as a percentage or decimal, whatever my math lab wants. And less than 4. There's 2 1s, 4 2s, 1 3. Add those dots up, you get 7. So it's 7 out of 16. More than 5. We got a 6. We got 3 7s. We got an 8. But don't forget your outlier way out here. We got that one way out there. So it's this little group is 5 plus the outlier makes 6. So there's 6 numbers bigger than 5. So it's 6 out of 16 proportion. Wonderful. And that's basically the science of dot plots right there. That's really all there is to it. Now let's talk about graphing qualitative data sets. Qualitative, once again from that basic terms and definitions list, is data whose values is categorical, not numerical. For example, if we were collecting data asking you what's your favorite color, your answer would be a word, not a number. At least we hope it would be. Or what are you majoring in? That's going to be a word answer. For example, if they were collecting GPAs, what's your GPA? That's quantitative because it's numerical. Pie chart. This is probably one of the most famous ones that people probably have seen before. All right. So let's see. Let me zoom in on this a little bit. And once again, you're not going to have to use Excel to construct these. Just basically is because you can, if you know the information and the data, you can kind of come up, if you're just picking the right answer, you can kind of figure it out essentially without having to do the fancy graph, or kind of what I'm doing here. Once again, we're asking a question. Now, this one, it doesn't, I used values to create this, but I'm not showing you what they are, but let's see. Now, let's say we just provided, you were only provided these 5 auto manufacturers. Yeah, obviously I didn't allow for every one of them. And out of these 5, Mercedes, Toyota, BMW, Porsche, and Honda, out of 600 responses, we're asking people to pick one of those 5 as their favorite. So a pie chart, what it does, it breaks down, the whole pie is 100%. So each little section of it is a percentage of the pie. So obviously half the pie would be 50%. Let me just draw this in here real quick. Once again, it's going to be rough because I'm not using a stylus, but it's not going to look great. So like I say, that, like this, half to each side would be 50. Yes, this really is rough, but anyway. So like if you broke it down in equal fourth, that means each section would be 25% of the pie, that sort of thing. So it all adds up to 100% of the pie. Let's get rid of that ugliness. Now, so it's not showing you the numbers here, which is easy to construct a pie chart if you have the numbers. I might make up a quick example for you. Like I said, you're not going to have to actually do this. Let's see if I've got one. Well, all right, I can even do that one again if we want to. If you just want to see how it's done, we can do that. Now, all right. So this says, suppose there were 600 people. How many chose Mercedes as your favorite? So what we're basically saying is how many X out of 600 equals 16, Mercedes right there, you can see it's 16%, which decimal will be 0.16. So we're saying X divided by 600 equals 0.16. So to solve for X, you're just multiplying both sides by 600. So it's 600 times 0.16 gives you 96. So all you do in this kind of question, if it's on a test, is, and it oftentimes is you just multiply your total by the percentage of whatever item it's asking for. So obviously don't be sure that you're checking, if it says Mercedes, be sure you're multiplying by the Mercedes percentage. So 600 times 0.16 is 96. That means 96 out of those 600 people chose Mercedes. Now this one's kind of a weird 477 number. I haven't really looked into these things, how to make it display decimal. Once you get into Excel, which we're not getting that extensive into it, but yeah, you can, boy, really learn how to get creative and do lots of stuff, you know, with it that we're not going to really worry about, you know, getting super fancy with it. But just the basics for this. This is not a Microsoft Excel training class or anything. But anyway, so we have 5 academic majors here, and there's 477 students. About how many students were business majors? So essentially saying X over 477 equals 31%. So we'll multiply 477 divided by 31, and watch what happens. It's not a whole number. And the answer has to be a whole number because it's saying how many students are in that major. So what really that means, the pie chart probably should have decimals in there with those, you know, percentages should all have like a little extra decimal with it or whatever, so they're rounded. But anyway, long story short, you would use normal rounding here. You don't have to round up like you do in 2.1 with the class width. So if that was 147.2, I would just say 147. So we're just using the standard 0.5 rounding rule. So probably, you know, the answer would have been 148 students, even though the decimal, even though the decimal came out to be this, it probably, that just means that that 31% is probably some sort of decimal percentage, but that's okay. Multiply it, and if it's not a whole number, round to the nearest whole number. Beautiful. So here's one. I got this data somewhere. And actually, I mean, I can even just do a different one than this one. That's fine. Let me just make up something here real quick. What do I want to do? Colors. And without opening a 64 box of crayons here, do about 6 of them. Oh, I don't know. That's good enough. And I'm just going to make up some numbers here. I won't even worry about what the total adds up to. 36, 50, 12, 28, 33. I don't know why I was making them all even. And 11. Okay. Now I'll show you a little trick. If we want to know the total, we don't need it to do this. You go down and drag this. You just hit the center of it and you drag it right down. And in 2.1, I showed you that Greek symbol, that capital sigma, that little zigzag thing. You don't have to know that it's called sigma, but if you hit that button when you leave, that means it's going to put the total down there. So there you go. It added them up and put 170 down there. So that means, notice in other words, I wasn't trying to make it add up to a specific total. I just picked whatever. So what you can do is kind of highlight these cells. Come over here and do this. And you go to Insert. And let's see, Charts. That looks like some pie right there. They even got 3D pies. I don't know what's going on with these white wheelie pies here. I don't know what. I don't even want to know. But you can make it 3D if you wanted to. And now there's some that'll show numbers in there. I forgot how to get the label. Okay, that's a good display. That's not bad. And there it is. You could type, you know. But like I said, there's a lot you could do to this. But anyway, so it took each one of them and divided by 170 and made it into the percentages. Yeah, the funny thing about this thing though is that I use colors, which is okay, but it doesn't know that those words are colors, so it's doing, oh, but the red, you see the label over here, red is blue and blue is, yeah, it doesn't know the colors, so. But you could probably play around with this and make it show the color. But that's not important. It's just, you know, those are just words basically. But it means the red, which is the labeled blue here, that 36 represents 21% of the data, or almost 1/4 of the pie. And then 50 is the blue, which is this orange part, it's 29% of the pie, so forth, so on. So there you go. The idea is no one's expecting you to, you know, become a Excel wizard here by any means. I'm just going to kind of show you what you need for this class. We'll be doing some interesting, helpful stuff with it later. This one showed the percentages for this thing by degrees here or whatever. So, okay, bar graphs for qualitative data. Now we had a bar graph in the last section 2.1 called a histogram. That was for quantitative data. And histogram generally means that the bars should touch together. I've seen some that don't, but it's really better if they do. Now these kind of bar graphs, they generally don't touch, but I guess they could, but most of the time they don't. It's probably better if they don't touch, but anyway, so these are, but they're based on qualitative data. Like for example, here's that Mercedes. Now I used the other one, the total was 600. I didn't have a breakdown. I'm not saying the percentages are even the same, whatever, the percentages might be the same, but anyway, so this one adds up to 200, and there's the frequencies for each one and the relative frequencies for each model. Now I can put these in Excel. I'll probably do a different example to show you, but mainly the key is on, well, I can do the, you know what, I could do the color one. Yeah, I'll do the same one, the color one. Now these, unlike histograms are always vertical, but bar charts can be vertical or horizontal. If they're horizontal, that means the frequency number will be out, so it sticks out as far as the frequency. So you see the Honda sticks out here to 58. So there's 58 right down here on the x-axis, right there, almost to 60. So it goes this way, or they can be shown vertically. I don't know what order it's choosing here. I do not know. When it's going, okay, well, I guess it's going horizontally. It's starting, okay, Mercedes, it starts at the bottom, so it's going down, goes up here, and then it goes left to right this way. That doesn't matter, but. So the difference between these two is, the only difference is it's frequency on the blue ones versus the axes, either X or Y is either frequency. Here it's relative frequency. It's just whether it's just showing it as a percentage. You see I wrote it right there. Of course, it showed it as percentage. It didn't show it as, but that's okay, because it's easy to make a decimal into percentage just multiplying by 100. So 0.16 is 16%. So you see Mercedes sticks out here just a little bit between 10 and 20, a little above it, makes it 16%. And so it can be displayed either way, relative frequency or regular frequencies. Oh, let me jump over here to this one. I'll get rid of the pie here. We'll just kind of right click on the corner, and it didn't cut. There we go. So we highlight the cells, and let's go over here to insert bar. Yeah, that's real basic, nothing fancy. I'm sure you can do, yeah, a lot more options here to see what it'll do and show. And all right, so there, I like that one. Shows the frequencies, the actual numbers there, so you can see them. Red, blue, green, purple, pink, yellow. Labels on below, so obviously there's no color associated with this. You could probably change them, but yeah, there you go. So there's a bar graph. I won't worry about doing the sideways graph, but so there we go. Pretty exciting. All right, here's an already done bar graph for you. So once again, it's just how to read off of this bar graph. Like I said, that's important skill. Like I say, constructing in Excel is not a critical skill for us in this class, but answering questions. What percent of these 5 providers are Sprint? And of course, as I record this video, I need to probably Sprint and T-Mobile are the same thing now, but anyway, that's all right. So now, first of all, how did I come up with a 37? It doesn't show us anywhere. It doesn't show us the total. It doesn't show us 37. Well, I did that by adding up each of the individual values. So you see the frequency. This one is 10 plus the height of 6, 8. That'll be 9, and that'll be 4. Add those up, you get 37. So that's where that total comes from. That's usually the first question people will ask me is, how did you get 37? If I'm doing a live lecture. And Sprint, just look at the numerator then, be how many were Sprint right here, which is 9. So it's 9 out of 37. So whether it wants decimal, percentage, whatever, we can answer it from there. Beautiful. A Pareto chart is a bar graph that intentionally sorts the bars in terms of decreasing height. It's often used in business. People want to see that, look at it, whatever. There could be like problem issues with a work type thing or something, or a business, and then you want to just, and it's easier to look at them if they're sort of sorted, especially if you have a lot of them. So this one, top 5 causes of death. This one obviously isn't a business one. I won't read all those out. You can see them. But if you come down here, unlike just a regular bar chart, the order doesn't necessarily matter. Excel would just graph these in the order we see them if that's the way they were typed in a spreadsheet. But here, it's taking the largest one first, which is heart disease. Right there is the largest. Plotting that one, that's in hundreds and thousands. Cancer was the second most at 599, blah, blah, blah. Accidents, 173, that's third. Lower respiratory right there is 156, and the lowest is stroke, 150. So they're always sorted highest to lowest. So that's not too bad. Some Pareto charts also do a line graph combined with it, but this book doesn't, so I'm not going to worry about the line graph. So this one, I just did this one in Excel. I won't go into the details of how I constructed that thing because, like I said, it's not important. But it won't be difficult for you to, I think, to pick the correct answer out, whether it's a homework or a test. That's all that matters, just from the numbers. So here are these values. I put them in Excel, and then I figured out how to use the Pareto. I've already forgotten, but how to use the Pareto in Excel, and played around with it a little bit. So there you go. So you see that new car dealers, Better Business Bureau customer complaints. I went ahead and titled it. Number 1, new car dealers, so it's up there real high. Number 2, the second highest, collection agencies. 3 is insurance companies. 10871. The fourth one, roofing contractors. And then 1687, that'll be the lowest. So it's just taking these and showing bar graphs, but always in decreasing order. Time series plot. Okay, this one's not difficult either. Time series plot means your x-axis is going to be some unit of time. Now, this first example is monthly. It could be monthly, it could be daily, it could be yearly, it could be hourly. It's whatever you're trying to measure per whatever unit time you want it to be. So the x-axis is a label based on a time frame, and then the y-axis, you put a dot to represent the height being the frequency. So it's like you put a dot at each height. So there's January, there's February, and then I think I added these dots manually. It only had the lines. I wanted to show the dots for emphasis. I guess the dots technically don't have to be there, but I think it looks better with them myself. But anyway, yeah. So then you draw a straight line. So from January, February, you draw a straight line between those dots, and you draw lines connecting all those dots. So I think this one I did in Excel. I chose an option. Yeah, I had to choose an option to where it put the dots in there, which is what I wanted. So here's, let's say, weekly blood pressure. So somebody's recording their blood pressure each week. Maybe going to show their doctor, whatever, and systolic, diastolic. So each week, 1, 2, 3, 4, all the way, say 13, just pick 13 weeks, just whatever we wanted there. And there, see, so the blues plotting all those systolic heights right there. And it drew the line connecting the dots like that. And then here's the one for the diastolic. And there you go. So I don't think reading a dot plot is too difficult. Okay, just take a quick look at this. How sometimes people can give you sort of misleading graphs. I mean, I'm not going to do that to you, but just in general. It doesn't mean that because you can distort the shapes of graphs, even if the figures are accurate, to make it look a certain way. Now, I forgot where I copied this from, but this is that symbol's in British pounds. So somebody wanted to say massive increase in home prices this year. So you got a thing at 80. So I'm not saying these could be perfectly accurate. We're not saying this is a lie. But the way the y-axis is scaled, when they draw an 80, they put it at 82. If you just look at the bars, it does look like a massive increase, doesn't it? It looks like more than double from one year to the next. But you look at the values, it didn't. It's only increased by 2,000. It didn't, but they were trying to show it more significantly. But if someone had used a better scale here, like this graph is, it's scaled much better. So you can see, yes, it's an increase from 80 to 82, and like I said, this is showing 80 to 82, but they distorted the image to make it look worse. They didn't necessarily lie, it's could be accurate, so it was a slight increase. It was not a massive increase. So that's what I was talking about. You always got to look at your y-axis, on things like that. This one's not a big deal, but this one they sort of did a similar type thing. The vertical scale is weird. 1, 2, 4, 8, 16. It's kind of weird. So I'm not sure what they're trying to show here, but whatever it is, it's because the scale is weird on the x-axis. But there's what the graph should really look like. So the first one to me was really more telltale than this one. This one is. So all right. So that will end the lecture component of the show here. So it's time for my math lab and take a look at some problems in there. All right. Let's take a look at this stem and leaf. That should be interesting. So we've got our data right here. So I'm going to put it in Excel. Open it up. Enable editing. I'm going to zoom in on this a little bit. So I'm going to highlight all these cells, and then drag the mouse down and do my usual data sort. Now for stem and leaf, obviously you don't have to do this next little trick, but I'm going to show it to you anyway, just because it's fun. We can make these go sideways by doing something called transpose. If you don't need to do this, don't worry about it. Cell range, if you actually, a lot of you probably never used Excel, maybe, I don't know, but the way you do a range of values, it's in, the first one's in cell A, row 1, and you use a colon to get to where the last one is. I should have looked before I did this. It's 24. A24 is where that 59 is. So that's how you select a range of values. You use a colon. So what it's going to do, it's going to take those values sorted vertically, and it's going to make it go left to right. And hit enter. Woo, magic. I'm going to do something else here. I'm going to format the column width. I'm doing way more than necessary, but well, you never know, you might pick up some useful stuff here. Make it a little narrower. Make it like 5. And I'm going to center all the values. Right there, where that arrow is, that's how you can center numbers if you want to. Yeah, okay. That didn't get them all in there, but it got them closer to the end. I like that, because remember the stem and leaf, we're putting the numbers in sideways, so looking at this sideways might make it helpful. If not, just go vertical. Do not worry about that. Not important. But it gives you a sideways view. We only got, let's see what we got here. We only got one number in the 20, 25, so that's going to be, so what is this data is? Number of hours nurses worked per week. So that's the end of that one. Now, the 30s. We don't have to put them all in there at once. We can go look and then do, so I see a 30, a 32. My memory is not so good, I'll forget. 30, two 32s, two 33s, and a 35. So I'm going to have leaves of 0, 2 2s, 2 3s, and a 5. 0, 2 2s, 2 3s, and a 5. We're not finished. No commas or anything between them. Just enter them just like that. And let me go get the rest of them. I'm sure those of you with younger, fresher brains than mine will be able to memorize that entire row of them. 1, 2, 3, 4, 4 36s and 1 38. Oop, oop. So 6, 6, 6, 6, 8. So that should be the end of the 30s. What do we got for 40s? Start scrolling over. A lot of 40, the number 40 itself. 1, 2, 3, 4, 5, 6, 7, 8 zeros, a 6, and an 8. All right, I can do that. I hope. 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. 6 and an 8. 50s. 2 and a 9. 52 and 59. Oop. Is it going to let me check it here? It is. Oh, oh, there we go. All right. Do we have it? Yes. Okay, one of these kind of questions. Most nurses between 30 and 40, I guess, would have to be the right one, because you see its leaf sticks out a little farther than the 40s. Like I said, this kind of thing I don't put on a test, but I like it. Makes you think about it a little bit. Excellent. So I already looked at the ones I wanted to do here. 4, 6, and the dot plot there. I'm not going to waste your time with a dot plot. All right, this one should be pretty easy, but I wanted to do a Pareto. There's only 4 values. We don't have to even, you can download the data here, but we don't need to. With only 4 of them, we can see which is the largest number. There's 6,200, 8,600, 11,000. That's your biggest number. It's SUVs. So right off the bat, you look at your answers. You got to start with SUV. Pareto goes largest to smallest. So right off the bat, A and D are eliminated because they start with medium. So it's either B or C because it starts with SUVs. What's the second largest after SUVs is minivan. 9157 is greater than both of those. So minivan's a second. That has medium a second. So minivan right there. And you can look at the rest of them just to make sure, but this has to be the right one because the only one that goes SUV, then minivan. Wonderful. Oh, no, I don't. I guess there's more. The greatest average cost to own, I guess SUV. Operate, and which one's the smallest? Is the small sedan. I didn't. You see right there. It's the one on the right. Okay, now I got it. Let's jump to number 10. That's a time series. I think you should be okay with that. I'm betting. I will tell you for this one, that's the answer for that one. Like I said, I wouldn't. It's sort of trying to say it's misleading because it's sticking the third quarter more in your face because stick 3D makes the fatter part. I guess that's the entire question for this one, so I guess I did it. Okay. So just get that one right, no work. That one's okay. That was all right. I might leave that one for you, but it was number. Oh, there's more to this question. Okay, yeah, I'm going to leave it anyway. That was okay. And there's another pie, but we got a pie coming up on this one too, I believe. Let me double check. Yeah. Want to at least do something with a pie in it. Okay, relative frequencies. So let's download this data. Now you can take a calculator and divide each one of these. First, but I'm just going to show you how to do this a little quicker in Excel, but there's nothing wrong with doing the calculator for each one. I never make you do anything. I want you to be comfortable. Show you how to actually do a formula in here. I need the total, obviously, then to be able to get these relative frequencies. So I need that total. So I'm going to show you how to get I'll move them over here. All right, let me show you an Excel trick here. I'm going to put equals the first cell range I want there, the 155, that's in B2, divided by. All right, I'm going to show you a trick here. Now, the totals in position B8. Now, I want to put dollar signs on this, like that. And I'll tell you why in just a second. Now, to copy a formula and drag it down, you come over, and if you like we were doing earlier when I was counting those cells, I just put my cursor right in the middle of the cell and drug it down. But to actually copy contents, you go over there to the right corner and do this. Now, here's the reason why I put the dollar signs in there. Because when you drag this down, it's changing. Let me show you a little command over here. You don't have to know this, but you'll be seeing me using this one a lot later too. But this is just so, because I learned this one because this is more for illustration because you'll see the formula up in that top row, but this is easier to see. Like, oh, this will be easy. It's much better to show students this. And I'll drag that down. So, did I not drag this formula down far enough? Oh no, it's the same number. But why did this, they're both formula text. Oh, this is wrong. Wait, what did I do? Yes, B2 The watch formula text here showing. Oh, I started. It should be D2 right here. Oh, okay, I screwed up. All right, that's why it was in. Okay, there we go. I didn't do the calculation wrong. I did this part wrong. So now it's showing you the formula. So you see, when you copy a formula, the cells that aren't, the dollar signs are like locking something in position. I wanted all these cells to change. I wanted them to go to 2, 3, 4, 5, 6, 7. But I wanted the denominator to be that 517 every time. You know what? You could have just, once you got the total, you could have just put 517 in there. But that's also fine. It'll just stay 517. But I want to show you this. So that locks it in there. So that means the numerator's changing like I want it to between each frequency. But the dollar signs lock in the denominator being 517 at all times. So there you go. But you could have just put 517 in there. So let's see what it wants. It wants, okay, always read what it says there, 3 decimal places. Now we can round these, or I can let Excel do it for me. I could probably squish this in, or I can just go like this. If I highlight and go format cells, number, and then I can choose decimal places. Or you can look at it and round it if you, that's fine. You don't have to do this. I'm going to center that. That bugs me. Doesn't matter. There we go. Yeah, so now they're already rounded to 3 without you having to think about it. So I'm going to go with 0.3, it's 0.300 and 0.217. I should have tried to memorize 3 at a time. Would have gone a little faster. I wonder if my brain will let me do 4 in a row. Probably not. Well, since the last 2 are the same. 203, 110, and 85. And 0.085. Back to back. All right, oh, that means another video I was working on just finished. All right, please ignore. Yeah, I was processing the video from 2.1. That means it's done. All right, so let's check it. Come on, be there one time. Got it. Oh, continue. Okay. Pie chart. Well, first thing I'm going to do is look at the ones that have the right numbers for the frequencies up here. Because you just convert them to percentages, multiply by 100, so we can probably eliminate. In other words, it's got to go 30.0%, 21.7%. Then we can see if the picture makes a difference or not. Well, the only one that can be right here is A, because the numbers are wrong in the other ones. Unless, oh, it's doing it by color. Well, okay, that's still, that's okay. It's still the same thing. It's still, yeah, I'm okay. I'm overthinking this. It still should be A. Oh, more fun. Bar chart. Now, this one's got them stuck together. I hope that's not a difference. I mean, there better not be a difference in the answers. That would be kind of strange, but we'll see. This will be an interesting one to see if. So we're going to look at it by, because it didn't say Pareto. They don't have to be in order. 30, 217, 203. Although this will be a Pareto actually, because they're already in order. They're in decreasing order just by chance, I guess. So which one of these looks like they're in decreasing order, with the last 2 being tied? This one's clearly wrong because the last 2 aren't tied, and it goes down then up. C or A? Relative frequencies, and the numbers look good. Let me check the scale on the axis. Sometimes that can be different. 0.2, okay, these are the same. Well, this is kind of tricky. I'm going to hope it's the one where they're not connected, because that's the way I would sort of explain it. But they do have the same shape. Okay. Yeah, so they're going with it. They're trying to trick us on the connected or not deal. All right. Is that it? Okay, there's no more parts to that problem. So, well, that's going to conclude this video for 2.2, more graphs and displays.